Thank you. I appreciate the opportunity to talk a little bit about what we are doing at Infleqtion. I'm Dr. Glenn Clark. I'm the Vice President for Quantum Development. I've been with the company now for almost 4 years, and my job is really to help the company transition from where we started, which is really as a research as a service organization, doing work with the DARPAs and the ARLs and AFRLs of the world. Now to product development, where we're rapidly maturing these technologies into product lines that are beginning to transition into operational use. I will say that in 5 minutes I can't get into a lot of depth. I absolutely encourage those that are on to take a look at our website. There's a wealth of material there that goes into a much deeper level on each of the different products that I'm going to talk about today. So let me start with the history of our company. We've been around for a while. We're actually in our 19th year, so we're not quite a new start. We are about a little bit over 200 employees. A pretty high percentage of those employees today are PhD physicists and engineers, but where we're seeing most of the growth, again, driven by product development, is really on the engineering side. So all of the engineering disciplines, which are key and critical to designing, to fabricating, manufacturing, transitioning, and then maintaining these products over time, that's what's all coming into play today at Infleqtion. This all started back in the early 2000s. Dana Anderson, our founder, working with Nobel Prize winning physicists at CU Boulder and the General Quantum Institute, started the company. And the company initially was focused on advancing certain core component technologies, which are central to understanding the physics of things like Bose-Einstein condensates and room temperature atomic systems. That's where it started, and with the development of those kinds of cells, those various types of cell technologies and supporting systems. Over time, things have grown rather rapidly. I'd say in the last 5 years, we've seen this shift from doing basic research now into initial commercialization. This started with our optical atomic clock, which I'll show you in just a minute. And today, that is a product. It's available. It's in low rate production, and it is being transitioned into operational use. It's very exciting. But in addition to that, we've made some pretty significant advancements in our RF technology, which is based on ripple electrometry. That is now starting that PLC process and will soon be transitioning into operational use. And then similarly, there's been significant growth or advancement in our cold matter atom-based interferometers, which are used for things like inertial sensing and gravity radiometry. And so this is us. So again, we're a quantum company, and the modality that we use across every single one of our products are atoms. And we use basically either the quantum electronic states of the atoms or the cold coherent states of atoms, or combinations of the both, to create different types of products with different applications in mind. So as I said, we started with developing the core components, mostly in support of research and development at academic institutions and research labs around the world. Here's an example of one of these exquisite cells that we developed today. It is almost like a jewel if you look at it. There's atomics, micro-optics, electromagnetics that have all been integrated down into a small cell that you can hold in your hand. And with this, you can do some pretty extraordinary things with atoms. In particular, under our sensing business unit, you see here in the center, we've been able to use this core technology, the same atoms, same kind of cells, the same kind of laser systems, to build things like optical atomic clocks. Ticker is our first product in that category. It's roughly about 10,000 times more precise than the current chip scale atomic clock, 1,000 times more precise than the current cesium standard, and is being looked at seriously for GPS-independent, ultra-stable timing for precision navigation and timing customers. Skywire, that is our quantum RF receiver system. It's again a compact receiver, about 1 cubic centimeter in size, integrated atomics, micro-optics, and electromagnetic. So I was just wrapping up on Exact. That's our cold matter-based interferometer used for inertial sensing, gravity gradiometry. Lots of applications in oil, gas, mineral exploration, precision navigation, and so forth. We also have a couple other business units that aren't really relevant to today's discussion, but they are very interesting. Compute Scale is our neutral atom quantum processor. Today, it's one of the largest, if not the largest, neutral atom quantum processors in the world at 1,600 physical atoms or qubits. We have moved on to doing logical qubit processing. In fact, I think we may be the only company in the world today that's actually using logical qubits or error-corrected qubits to do computations. And we've demonstrated this recently at the Quantum at a variety of different conferences, including QTV and the World Quantum Congress, where we showed a 12-bit implementation of Shor's algorithm and its use to factor small numbers. And then over under the software business unit, it's started with our acquisition of SuperTech and SuperStack, which is a full development environment, allows you to develop it using high-level languages. And we do the hard work of translating those algorithms into quantum circuits and optimizing them for whatever the underlying hardware is, whether it's ours or somebody else's. And then we've made huge strides in now developing things like contextual machine learning, which is one of our quantum-inspired algorithms that is getting a lot of use today in a variety of different applications, including PNT, where we're using it to fuse multimode sensor data together to create better solutions, for position navigation and timing. We're also using it to improve the real-time performance in detecting and processing of RF signals. And in general, it really just opens up the context window in whatever degrees of freedom are available. So in time and space and in frequency, to enhance the ability to detect correlations in all those domains and improve overall sensor performance. So with that, I will hand off the baton here to the next speaker.